Alright, problem 3C, same deal as before. We want to figure out a way to write the general term for this series, and if it's geometric, we want to actually state the ratio and determine for which values of x this series will converge. So I'm going to do what I've done many times before. I'm going to list the term number below each term. Again, that can be really helpful for recognizing patterns. So if you look at these terms, notice that there are two distinct pieces to it. You have that integer coefficient out front, which looks like it's in multiples of 3. And then you have that x plus 1 factor that looks like it's increasing by a power each time. So kind of two separate pieces to this. So if we start to build our function, a sub n, that is going to equal, well, think about what we just said. It seems to be increasing by a power of -3 each time. 1 times -3 is -3. -3 times -3 is +9. 9 times -3 is -27. So we definitely have a -3 in this. So okay, before I go further, think about 1 is like -3 to the 0. -3 is like -3 to the power of 1. 9 is like -3 squared. And -27 is like -3 cubed. So you can see each time our exponent is 1 less than our term number. So we're going to get an n-1 up there. But then don't forget we also have this x plus 1 factor that's increasing each time. So let's do the same exact thing we did with the integer piece. It's not going to be any different. So think about it. We have factors of x plus 1. Well, the first one has to be 0. Second one has to be to the power of 1. Third one has to be to the power of 2, etc. So it's actually following the same pattern as the 3 was. It's x plus 1 to the power of n-1. And so we can write this more conveniently as 3 times x plus 1 all to the power of n-1. And if you do that, maybe you can recognize that this is actually geometric, right? We've got our first term just happens to be 1 times our common ratio. Well, we're multiplying by 3 times x plus 1 every single time. So our common ratio, r, is actually that expression, 3 times x plus 1. And I'm noticing I dropped my negative, so that should be a -3 in all of those. So again, use what we've said before. For this series to converge, we know that r has to be greater than -1 and less than +1. So let's just go ahead and substitute that r value into our inequality. We're going to get 1 is greater than -3 times x plus 1. And we're also going to get -3 times x plus 1 is greater than -1. And we just need to solve these both for x, and then we will have our range of x values for which this infinite series will converge. So I'll divide by -3 on both sides. I'm going to work both problems at the same time. 1 divided by -3 is -1/3. -3 times x plus 1 divided by -3 is just x plus 1. And remember, since we divided by a negative number, we have to flip the orientation of our sign. Same thing over here. Our -3's are going to cancel out, so we're going to get x plus 1 on the left. And -1 divided by -3, we're going to get a positive 1/3 on the right. And we got to flip that sign. So subtract 1 from both sides of both equations, and we're going to get -1/3 minus 1, which is -4/3, is less than x. In the other equation, we're going to get x is less than 1/3 minus 1 is -2/3. So let's combine those two. I'm going to use the powers of technology to do that, and we're going to get, boom, negative 4/3 is less than x is less than negative 2/3. So we've got our general term, a sub n, we've got our common ratio, r, and we have our range of x values, our interval of x values, for which this infinite geometric series will indeed converge.